357 is one of the most important lessons in Masonry. When you are introduced into the Masonic order, 357 is one of the most important number sequences that you're going to learn. The 357 principle in quantum growth. So 3 represents foundation, wisdom, strength, beauty. The 5 represents refinement, such as like the 5 senses, the points of fellowship. The 7, perfection. 7 is in the liberal arts, symbolically mirrors quantum scaling and developmental stages. Brother, we will pursue our journey. The next thing that attracts our attention is the winding stairs, which leads to the middle chamber of King Solomon's temple, consisting of 3, 5, and 7 steps. The first 3 allude to the 3 principal stages of human life, namely youth, manhood, and old age. In youth, as entered apprentices, we ought industrially to occupy our minds in the attainment of useful knowledge. In manhood, as fellow crafts, we should apply our knowledge to the discharge of our respective duties to God, our neighbors, and ourselves, so that in old age, as master masons, we may enjoy the happy reflections consequent on a well-spent life and die in the hope of a glorious immortality. They also allude to the 3 principal supports in Masonry, namely wisdom, strength, and beauty, for it is necessary that there should be wisdom to contrive, strength to support, and beauty to adorn all great and important undertakings. They further allude to the 3 principal offices of the lodge, for example, the master, the senior, and the junior wardens. So when you're building the stairs, using the 357 principle, you get the winding staircase. Now, what's the winding staircase in your body?
DNA.
DNA. All right. So why would they want to utilize the winding staircase ratio of the 357 Masonic principle and build? Because are we not building a world? When you're building a quantum computer, you're essentially creating a hard copy as well as a soft copy algorithm to create a universe, so to speak. And we know that all of this stuff is to join with AI so that sentience can be created, so that they can mimic the mind and the brain, because they want to be able to interface, so you can have limitless possibilities. So I find it quite interesting that in order to overcome the error correction, that they went ahead doing so by using the 357 principle of Masonry. Now, what does this have anything to do with the problem I originally said? Because problem 47 is the 47th problem of Euclid. Euclid's 47th problem is the Pythagorean theorem. A squared plus B squared equals C squared. When the squares of the two equal the hypotenuse, the two sides equal the hypotenuse. This is how you do what? You build. Now, when we're talking about Solomon's temple is philosophically, right, is the brain, the mind. So when you read in the Bible about them having all of, the cubits and how they measure the curtains and they need this many of that and that many of that, they're talking about the construction of the brain, which is this interface between these other dimensions, these other multiverses in here, where waves collapse into reality and we experience time. This is what Solomon's temple is. So in order to build these amazing structures in Kemet, amazing structures in Tartaria, amazing structures throughout the world, the Pythagorean theorem, or really the Kemetic theorem, because this was used with Osiris, Isis, and Horus. That's what the three different squares represent. The two sides equaling the hypotenuse, meaning Heru, he ends up being what the two combinations create. This particular mathematical problem is what is utilized in order to build a structure. However, the 357 is the ratio that is utilized. So you have this structure here, which is the a squared plus b squared equals c squared. This is known as the 345. Okay, the 345, because you have the 3 by 3 square, you got the 4 by 4 square, you have the 5 by 5 square. It's the ratio between those two. So that 345 equates to building the structure. The 357 is how you integrate structures within the structure. Why do you integrate structures within a structure? Because you need windows, you need doors, you need partitions, you need stairs, floors, right? Ooh. So it's one thing to create a metaverse, a space. It's another thing to build out that space. Y'all following me? All right. Now, we're talking about numbers, and with numbers, we have to talk about the Tetragrammaton, because we know who they all praying to. You know they praying to Yahweh. They praying to the Tetra. Now, the reason why the Tetragrammaton comes into play with all of this so much is because I should have worn
my Yahweh shirt today. I'm sorry.
You said you got one today?
I said I should have worn it, but go ahead. I'm sorry. Go ahead.
You should have worn.
This is good. This good, man. This good at KT. Well, go ahead, my brother.
So when you're talking about the 357, the 357 is very important because it goes into infinitum, that winding staircase. That's that D-A, right? That's that spiral. That's that vortex. It essentially is a divergent equation, meaning that divergent means that it expands, right? It opens up, it flowers up, right? So the infinite sequence of triangular numbers, this is a thing called triangular numbers. Y'all see triangular numbers every time you play pool, right? Every time you play pool, right? And that thing is all about geometry and angles, right? You got to lay those billiard balls in that triangle and then you crack that thing. The infinite sequence of triangular numbers, okay, diverges to plus infinity. It's saying that triangular numbers diverge, they open up, they expand into infinity. So by definition, the infinite series of triangular numbers is 1 plus 2 plus 3 plus 4. Tetragrammaton, that's 4. Yahweh, Yod, Hey, Vo, Hey, the 4, right? 1 plus 2 plus 3 plus 4, right? 1 plus 2 plus 3 plus 4 plus diverges. The divergence is a simple consequence of the form of the series. So what you see on the right is when you use this equation, 1 plus 2 plus 3 plus 4, you start off with the billiard. You start off with one ball or one dot, and then you get 3 dots, and then you get 5 dots. You get 6 dots. Sorry, then you get 10 dots, right? Then you get 15, and then you get 21. And these numbers are coming because what they're doing is they're adding the numbers together. So the 1 is on its own. You add the 1 and the 2, you get the 3. Then you add 3 to that 3, you get the 6. Then you take the 6, add it to the 4, you get the 10. Then you add the 10 to the 5, you get 15. And then 15 to the 6, you get 21. And as you continue to do this equation, look how the triangles constantly are formed. Look how they keep making these equilateral triangles. Now, why is this important? If we're talking about hopping dimensions, remember, you go from the dot, the black dot, right, to the ray, the line, huh? But then you have a vector, which is 2 lines, but the first plane going from line to plane dimension, the first plane, the 2 dimensions is what? A triangle. And from the triangle comes the square and every other type of plane until we jump and go into 3 dimensions with cubes and everything like that. So what I'm showing you here is through the numbers, through computational power, how geometry can turn into form, can turn into structure. Let's push forward. Let's push forward. Where is my slide? Hold on. Let's go back. 357. I wanted to put, I must not have wrote it down. It must be here. Okay, yeah, it's on here. All right. Now, when you take 1, 2, 3, 4 and you square them, because that's what we're talking about right now. So you get 1 to the second. You get 2 to the second, you get 3 to the second, you get 4 to the second. You're left with 1, 4, 9, and 16. When you subtract each square from the next one, the 4 from the 1, the 9 from the 4, the 16 from the 9, you get 3, 5, 7. So the code, the universal code that is embedded in reality in order to fill up space properly, in order to create levels in a floor and drop error exponentially so that you can create some type of amazing Tartarian superstructure, is through this 3, 5, 7, which they did with this willow chip. 3, 5, 7. Okay. So the 3, 4, 5 and the 3, 5, 7, the 3, 4, 5 is the 47 problem of Euclid. This is what we was talking about in National Treasure, in the movie National Treasure with Nicolas Cage. Now, remember when I just showed you these triangles? Why are the triangles important? Because when we're talking about the digital world, when we went from 16-bit on Super Nintendo and Sega, and we went to PlayStation and Dreamcast, why were we so hyped? Because they went into using polygons now in order to create what? More of a 3D world we can navigate through. But we remember when we first was playing Tekken back in the day, or Madden or whatever back in the day. Remember them? Remember how that stuff used to look? Blocks.
Yep.
So look at this picture, how it says 60 triangles. But look at 600 triangles. Now look at 6,000 triangles. So you see the more triangles that are utilized in the rendering process of this form and structure, the more detailed it becomes. Now look at the design above them. That's the print on the mocap suits when we doing VFX, and you know, you're looking at the Avatar, you're looking at the Na'vi, they're wearing that suit. You're looking at what's the name playing the Hulk? He's wearing that suit. You know, homeboy that was Thanos, he wearing that suit. Why are they showered in triangles? Because of the 1, 2, 3, 4. Because of the infinite sequence. This sequence, this growth, is they're able to utilize this within the digital world in order to construct and to build. So now that they've been able to tie together the 3, 4, 5 and the 3, 5, 7 with this chip, they've been able to drop the error, and now they can do way more computational task. Now, the Tetragrammaton at 4 is important because it's the DNA. Those are the steps of the DNA, the cytosine, the adenine, the guanine, the thymine, right? Those are those steps right there. What else do we have? We got the north, south, east, west, right? What else do we have? We have the fire, water, earth, air. And then most importantly, we have the 4 worlds, Yud, Ha, Yod, He, Vav, He, where I talked about the Tetragrammaton with the Yod representing absolute, which is emanation, right? Initial inspiration. You got Bariah. This is you descending down. Creation. Bina is understanding. This is broadening of the concept. This is what we're doing with thought. This is what our brain, Solomon's temple. You understand? Initial inspiration, broadening of the concept. Then we got Yetzirah, right? Which represents the involvement in plans. This is formation. All right. And then we have Isaiah or Asia, action, which is building of the project. So look how these principles are all kind of tucked and packed into one another, that when they unfold, you don't have to do that much work because it's already encoded. Right. So if you're using the correct numbers, the correct sequence to create the correct principles, then things will unfold naturally and you don't have to micromanage. And if you're dealing with a quantum system that deals with exponential growth, then you can go from an initial inspiration and fold the paper to building of a project in no time. And this is what they're on the precipice of right now. Okay. So let's go to here. So 2 to the 105. Okay. The amount of qubits that they have in this chip is 105 qubits, which means they are able to access 105 quantum states. 105 different quantum states. Classical simulation and feasible due to memory and time constraints. Represents the number of quantum states in a 105 qubit system. Storing or simulating this many states is beyond classical computation capabilities. A classical supercomputer would require 10 to the 25th power or 10 septillion years to solve the problem Willow handled in 5 minutes. Quantum advantage demonstrates the unparalleled power of quantum parallelism, meaning parallel worlds. Because other than superposition, where I showed you the spinning quarter, quantum entanglement would be similar to if I flip the coin, right, and it lands on heads, there's a coin that is attached to this coin somewhere else in the world that lands on tails. And to make it a little bit more practical, if that's a little too woo-woo for you, just think of a seesaw. If I sit on a seesaw and somebody's on the other end, they go up. If they sit down on the seesaw, I go up. The board, the wood, is what connects us together. But in quantum entanglement, it's as if taking that board away and we both was on those both ends. And when I go down, the other person goes up. And when the person goes down, I go up. That's what quantum entanglement is. So it's able to have these linked results that take place, this connection over indescribable distances. Distance is not a problem. This is like a baby crying and a mama being in a whole nother city and her breast leaking. Okay, that's quantum entanglement for you. So in classical computing, each bit combination must be processed individually. A 105-bit classical computer would handle only one configuration out of the 2 to the 105th at a time. One at a time.